Oh, hi guys. Now I want to talk about the inclines, and before doing that, first maybe you should check what is this. I was told you about these problem-solving steps that you have in the page 88, and this is how you always have to do first. And I like they always tell you to solve this incline or well actually any of these problems with what involves the second law of Newton. So always you have to draw a sketch, the free body diagram, that you show all the forces acting on that object. Forces doesn't mean that the velocity or something like that. No, any force or acceleration. Okay. Then you resolve the vectors, like you have to pick the x and y axis, so you do it in the components, and you use the Newton's second law for each object. Okay, and finally you solve the problem. So usually this like they have you have this example with the that this is a very simple one, that you are pulling a box, that you have used normally you have the gravity, the force due to gravity, and the normal force, and an extra one that is the one that moves everything. Okay, you can check also this one, the two boxes with connected by a cord. The pulleys we're going to talk about later, and maybe this also, the accelerometer. Well, of course, another important force we have, that is of friction, which is always against the movement. So if you have velocity or you have acceleration, anything that intends to move, you have friction, which there are two kinds: kinetic friction and static friction. The static is the friction that in, in, doesn't allow one object to move for the first time, and the kinetic friction is the one that is acting when it's moving. Static friction is always higher than kinetic friction. Okay, and usually the formula is mu, which is could be the static or the kinetic times the normal force, and that's it. That's everything you need to know about this friction. Okay, so here they talk more about the static friction, and says that if something to make something move, the force has to be higher than this force of friction considered the static friction. Okay, here you have some examples. This is a nice graph that represents what is the force, the friction force versus the applied force, and when it starts to move, you can see that in the beginning you apply the force, and the friction force is the same until it starts moving. Okay, so this friction force is more like one of these third Newton laws forces that it it just contrasts the force that is applied. Okay, so you apply some Newton, some force, and the friction force that appears in the body is just exactly, but it's just in the opposite direction. And once it starts moving, the friction force is constant. Okay. Okay. So now the thing we were talking about is this the inclines. So the inclines always you have some kind of ramp that this has some angle, and you drop a body and see what happens. Okay. So you in this kind of inclines, we usually we define the axis like perpendicular to the incline is the y-axis, and parallel to the incline is the x-axis. Okay, we do it like this, so the normal is always just parallel to the y-axis, and then you have the gravity which is perpendicular to the ground. Okay, so it has an angle with the x-axis and with the y-axis. And of course the force of friction that is parallel to the x-axis. Of course, if it's moving along the x-axis, the force of friction is just parallel to the. Okay, when I say parallel to one axis, means that of course it's perpendicular to the other axis, and it means that it doesn't have components in the x-axis, only has component in the y-axis. Okay, so the only thing you have to here is to do is resolve this the force of gravity in the x and y axis, and you have this usually the b in theta, the angle that forms. So in the x-axis is mg sine of theta, and the y-axis is minus mg cosine of theta. And then you have to apply, you can see it here better, you have to apply the second law in the x and the y-axis, and you will get all, I think you will get all the equations, and you can solve for the problems. Like as an example, maybe I can show you like how to solve, like for example this 39, like the coefficient of static friction between hard rubber and normal strip pavement is 0.9. So how steep a hill must be so you can leave the car park. And this problem is one of these incline problems. You have the car here, and you have this down a hill with an angle. So again, you have to first decide what is make a sketch, free body diagram, draw the axis, and then decide which result of the vectors, and apply the second law of Newton in the y-axis and the x-axis. So you have this is the y-axis. You have the force of the normal force, the y component of the gravity, the force due to gravity, the s component of the force due to gravity, and the friction. So in the y-axis you have this minus this equals 0 because it's not moving, and the y-axis you have this, x-axis you have this minus this equals 0 because you don't want to move. It's what they ask. What is this angle? What is the maximum angle of the hill? So this guy is not going to go down along the x-axis. Okay. So here's in the y-axis, as I say, you have the normal force is equal to the y component of the force due to gravity. So the normal force is mg cosine of theta, and then the x-axis you have that the x component of the force due to gravity is equal to the friction because we don't want to move. So mg sine of theta is equal to the friction, which is mu times the normal, which is this one. So it's equal to mu times mg cosine of theta. Mg and mg goes away, so the mu has to be equal to the tangent of theta, which is, well, this is wrong, it's 0.9, and so this theta is the tangent of 0.9, which is 42. Okay, so they ask what is the maximum angle, 42. Okay, another one I have resolved is this one. Have a crate which is showing this in this figure, has one incline with an angle of 25 degrees to the horizontal, and the mu is 0.19. You have to determine the acceleration of the crate as it slides down the plane. Now it's moving along the x-axis, and if the crate starts from rest to 8 point, and it moves 8.5 meters, what is the crate speed when it reaches the bottom of the incline? Okay, so if you set the 0 point here, so it moves 8.15 meters along this x-axis. Okay, so this is have it in here. Again, this you can see it's always the same. You have this ramp, angle, the normal force, friction, gravity, force due to gravity, x and y axis, we define it as you already seen, you find the y and x-axis like that. So we check in the y-axis we have the sum of forces equals to the mass times the acceleration in the y, which gives again the normal force equal to mg cosine of theta, and the x-axis we have the same. Now the subtraction of these two guys, the x component of the gravity, the force to the gravity minus the force of friction equals mass times acceleration. Now we know that acceleration is the thing we want to compute, so the acceleration is equal to g sine of theta minus mu times the normal g cosine theta. The masses goes away and you get this, and it's 2.5 meters second square the acceleration. And to compute the v, now we know it moves 8.15 meters, so we use this formula, v squared minus the initial speed square equal to 2 times acceleration at the distance, which is 8.15, a is 2.5, so in the end we get this. Okay, so I think this, guys, this is everything I have to say about inclines. So these problems are more or less the same, very similar, so I hope you don't have any problems about this anymore. Okay, see you.